Hello, I hope you're all doing well. Welcome to week 2 of Environmental Management 2A, and we will be going on with part 1 of climate change. Here we will just deal with aspects surrounding climate change in general, such as explaining what it is, and also explaining it in context of anthropogenic activities, and then just also going over some of the effects of climate change, and then how we can slow this process down. All right. So, what is climate change? When we first talk about climate change, we need to first understand the difference between weather and climate, in which weather is said to take place on a much shorter time scale in terms of atmospheric variables, including temperature, the amount of rain received, wind speed, and also in terms of how we take these measurements on an hourly to a daily basis. So it's a very short time span in this sense. So when you look at the weather, you normally are looking at about 7 days ahead of you, maybe even up to a month. But when we talk about climate, it's a bit different because it is made up of the sum of the average weather conditions taken over a period of 30 years or more. So when we look at a specific weather period over 30 years, we then can specify as to how the climate has been, and this is how we have then sort of classified specific climate zones across the globe. So here we see those climate zones. Unfortunately, the key isn't exactly there, but it is kind of intuitive in that red obviously would mean dry, and as it goes to orange, it would be semi-arid, and then the green would be tropical to subtropical or semi-tropical. And so you can see in South Africa, we've actually got quite a few different climatic zones going on in there as it goes from a tropical zone into a near desert or arid zone. Okay. So climate change is a very natural thing. It's a very normal thing and has been happening to the Earth within its atmosphere over its entire 3.5 billion year lifetime. And in terms of a cosmic scale, the Earth is not only revolving around the Sun, but the Sun is revolving around the galaxy center, and that in itself is hurtling into infinity. Okay, and so over the eons, there have been various factors that have influenced or changed our planet's climate as a result of minute deviations at this solar scale. So if we look at the first one, these deviations they happen in what are called Milankovitch cycles. And if we look at the first one talks about slight deviations in the elliptical orbit of the Earth as it orbits the Sun. So the Sun would be like over here, and so sometimes the Earth might be further away at its closest point, or maybe closer at its furthest point, and that'll shape certain factors. And then the next one we see are small oscillations in the Earth's axis. So sometimes this axis might change every now and then. It might straighten, or it might go further down, and this will have different impacts depending on where the continents are, where it is in the orbit, so on and so forth. And this little axial tilt happens every 41,000 years, in which it oscillates. And then every 20,000 years there, we'll have a bit of a wobble where the Earth might suddenly, dip up or dip down, as it is going around the Sun. Okay. So if we have a look at a bit more of a local scale with regards to the Earth itself, there are various phenomena that have impacted our climate, the most obvious being volcanic eruptions as well as meteor impacts, which have emitted huge dust clouds and have thus served to prevent solar radiation from coming into the Earth. And, so this has, as a result, caused an ice age or two. And then we have also had changes within the sun itself in terms of the fusion process that takes place at its center, where hydrogen becomes helium, and this kind of fluctuates, and we receive either an increased or decreased amount of heat. And then we've also had various changes in our global circulation patterns, and this also has translated in changes in our ocean currents. And then also the existence of surface ice that might reflect greater amounts of incoming solar energy, and this has also served to further cool the Earth's atmosphere. And then we've also had fluctuations in the concentration of greenhouse gases. So a good example is that you had what was called the Carboniferous period, in which trees would lock up a lot of the carbon dioxide in the atmosphere, and there was no fungus that existed yet to degrade the wood. So when a tree would fall, it would just fall down and then just be buried, essentially. And so that carbon dioxide was constantly being removed from out of the atmosphere. And so as a result, that's where we get most of our coal. But the oxygen within the atmosphere started increasing dramatically in terms of concentration. So you had a lot more violent storms and wildfires taking place, but also Earth could support much larger animals, and that's also why you had such great dinosaurs and mammals roaming around at that time. And yeah, so just these minor fluctuations within the greenhouse gases can have an enormous impact over a large amount of time. Okay. In terms of ice ages, the Earth's atmosphere is very dependent on the presence of heat-retaining gases, these such as carbon dioxide and methane, and we call them greenhouse gases because they keep heat in the atmosphere on the planet's, and this kind of keeps the planet's surface warm like you would in a greenhouse. So as the presence of carbon dioxide, methane, and oxygen have increased and decreased over time, it has created a periodic freezing over or a warming of the Earth's surface. And this cyclical period has, you have a glacial or an interglacial period. So right now we are in what's called an interglacial period, in a sense, kind of forewarning, I suppose, of the expectation of there being another glacial period. So over the past 10,000 years, it's been relatively stable, and this has allowed us to develop agriculture, and there on we have been able to agglomerate larger populations and sustain them through cities. I really would like you to please have a look at that video link I've posted there. It explains a lot about ice ages, and the reason why I want you to watch it is because it also gives you a larger background in terms of Earth's history and how the climates have changed and how that has served to influence life here on Earth. And the reason why that's important is because we're so focused on previous prehistory as well as on present climate change in terms of what could happen in the next 100 years. We haven't fully considered what might happen in the next 1,000 to 100,000 years because of actions we are doing right now. So let's have a look at anthropogenic climate change. So recently, we have noticed that, especially since 1975, although since the 1900s, we have noticed that global average temperatures have been steadily increasing higher from what is the accepted norm. And this has been the same case for ocean temperatures, which have risen by about 1 degree since 1850. These changes are seen to be caused mostly by human activities, in which we have burnt and consumed fossil fuels, which then increases the amount of greenhouse gases in the Earth's atmosphere. And then we have also removed large amounts of the planet's forests, which has therefore also further reduced the Earth's natural ability to remove these greenhouse gases from the atmosphere. Okay, and the atmosphere actually generally favors a greenhouse environment, and so our actions are thus magnifying the impact that they cause, and this is causing a rapid and harmful change within our climate's natural perturbations, and this impact will be felt at an environmental, economic, and social scale, in which the benefits that these greenhouse gases normally provide are now being amplified to such an extent that they are now causing a threat to life and to all life on Earth. Yeah. So, if we look at climate, remember that climate is taken over a period of 30 years. And so over the past 100 years, we have shown that climate is definitely changing, since global average temperatures are definitely beginning to deviate. And this has been linked to our industrialization, because pre-industrialized atmospheric levels of carbon dioxide before the 1800s were shown to be at 280 parts per million. This now in 2019 has been shown to be at 415. So you can see that it has markedly increased since 2005 and even higher since 2018. Now, how do we measure the concentration of carbon dioxide before, over 200 years ago? How do we know what the concentration of carbon dioxide was then? Within the Arctic and Antarctic regions, scientists are drilling down ice cores. So what they do is they bore down a hole and then pull out a tube of ice, and these tubes reveal layers. And as you go down the layers, you go down into prehistory, and these layers are caused by dust particles in the atmosphere, even gas particles in the atmosphere that deposit onto the fresh snow in the Arctic and Antarctic regions, and then more snow will then fall over that, and it'll be preserved. So you can even count, well, they kind of look at carbon dioxide bubbles in the ice that forms, and then they're able to kind of estimate the concentration from there. And that's sort of how we measure prehistoric atmospheric gas levels within the atmosphere. And then also that's how we can see where there was a volcanic eruption, or where there was even a meteorite strike based on the dust found within these tubes of ice. And the Antarctic is an incredibly ancient ice form that has existed for millions of years and is far older than the Arctic region. So a lot of information can be obtained from these cores. So just to get back on point in terms of anthropogenic climate change, the problem with climate change is not its natural process, but rather the rapid climate change that we are setting. And dealing with it is not really a straightforward process, since it transcends various political, economic, and ethical spheres. One of the main issues is that our economies are built around the consumption of fossil fuels, in which 85% of our commercial energy is derived from consuming them. And this has led to the expelling of greenhouse gases. Okay. If we look at other evidence in which there is rapid climate change taking place, we can see that most of our hottest years have been since 2010, in which 6 of the warmest years have been from 2010, and then 17 of our hottest years have been from the year 2000. And then there has been a decrease in the amount of pack ice floating since 1979, and the Arctic region has been the warmest ever since 2014. And this has ironically actually been improving transport routes between continental Europe and Asia with continental North America, since ships can now just sail across the Arctic Sea instead of having to go all the way around. And glaciers that have been over 1,000 years old, millions of years old even, have now begun to melt, and this has caused unusual flooding in what in places like Peru and Bolivia. And in Peru, for instance, in their capital Lima, which is a very dry place, is experiencing an unusual situation, since it's incredibly dry, but they're flooding, and there's no rain or whatever, but their riverbanks are bursting and buildings are becoming damaged as a result of these glacial melts. Now, this might be fine, since now they have increased access to water, perhaps, and they can use this. But in the next 30 to 50 years, it might be that they may have no water whatsoever. So this is also an issue. And then if we have a look at permafrost, especially in your northern hemispheres, where this soil has been frozen for thousands of years, and so towns have been built on these soils, and now they're starting to thaw, so starting to become soggy and muddy, and buildings are now sinking and becoming damaged as a result of this. And then also world average sea levels are rising as a result of melting glaciers, and in addition to this, oceans are beginning to warm as they absorb most of the heat that we produce. And in the atmosphere, there are concentrations of greenhouse gases are increasing since 1960, and then also the ocean has become more acidic, which is bleaching the coral reef. So, and this is mostly because of interactions of anthropogenic activities with the Earth's atmosphere, and this is causing all these different impacts and effects. So, what are these impacts? Well, they're uncertain, to be honest. We don't really know, because it depends on what we do right now. So this is what the Paris Accord was. So if we look at increasing temperature versus carbon dioxide, if we don't do anything, temperatures will only rise. But if we do something, we might be able to halt it, and might even see a tapering off of global temperatures as our carbon dioxide emissions decrease. So the rapid onset of the rapid discharge of greenhouse gases and anthropogenic induced climate change is creating various impacts, and some of these examples include increased rainfall intensity, in which a month's worth of rain can be received in a day or two, or we might not even receive rain at all, in which droughts become far more intense, lasting longer, and extending over greater regions of land. And then also our polar caps are melting, and this is now increasing the amount of fresh water in the oceans and is causing them to rise. And now we have a growing number of island refugees. Also, there's the melting of permafrost, which we talked about, and there are also threats to biodiversity as a result of microclimates beginning to change, causing many animals and plants to have to adapt, or otherwise they might perish. All right. So, what are the causes of climate change? First, we need to talk about the greenhouse effect. So this is a very natural process, which I'm sure many of you are quite familiar with, in which solar radiation is received on the Earth's surface and is then reflected back and in the form of infrared heat. And then due to the presence of of gases within our atmosphere, that heat is then retained or reflected back, and thus is able to sustain life on Earth because we have a steady temperature that is amenable to supporting life on Earth. And that is the greenhouse effect. We are very dependent on the presence of this atmosphere and the heat retention properties that they have. So when we talk about greenhouse gases, the principal gas that we look at is carbon dioxide, and this is often correlated to anthropogenic activities, in which currently the main reason why there's a great amount of carbon dioxide in the atmosphere is a result of us um, doing stuff with fossil-based resources. Okay, there's no other way that carbon dioxide got there. And other gases that influence greenhouse, the greenhouse mechanism include methane as well as nitrous oxides. And these two gases are also largely associated with human agricultural activities, such as from landfills, stock farming, so cattle farming en masse, and also certain fertilizer application methods will also dispel nitrous oxide. And then we also have fluorinated gases which interact with the greenhouse atmosphere, and these fluorinated gases are sulfur hexafluoride, perfluorocarbons, and then hydrofluorocarbons, which are mostly and these are mostly involved at various stages of manufacturing, but also in refrigeration and air conditioning. So if we have a look at these greenhouse gases, they have increased in concentration over the last 275 years. And these gases have different lifetimes in the atmosphere. And so this kind of also creates further challenges in predicting the severity of impacts based on our actions. So because carbon dioxide can stay in the atmosphere for almost 100 years, whereas methane will only last for about 12 years, but it can retain up to 34 times as much heat than carbon dioxide. Methane levels are also expected to increase as a result of thawing permafrost, which will then vent natural methane deposits into the atmosphere. And currently, methane levels have increased by over 70% over the last 275 years. And then nitrous oxides, they last in the atmosphere for up to 114 years and also retain up to 300 times more heat than carbon dioxide. So you can see that this is actually a very dangerous greenhouse gas that we emit, and it's mostly as a result of agricultural activities as well as manufacturing processes. And it's a very vague term, unfortunately, but the best way to kind of narrow it down is the fact that where you have factory sites, you are most likely going to have sites of nitrous oxide emission. So here we have a graph which correlates Earth's sea levels and its temperature with an increase in greenhouse gases such as carbon dioxide and methane. And you can see how there is kind of an alignment with these graphs, in which you can clearly see that the peaks of these graphs tend to align. We can see that as greenhouse gases spike, so do our temperatures and sea levels. And here's another example over here. So now we have a bit of a worrying situation in which carbon dioxide has spiked higher than has ever been in the last 400,000 years. And you can see that global temperatures have not yet reacted to that, and nor has the sea levels. And you can see that methane levels haven't necessarily been measured yet to the present, and it is quite likely that they might also have spiked. So who knows what will happen, because the whole worry is this 2 degrees to 4 degrees increase, in which that is a major tipping point, and that is why we're trying to keep our levels under 1.5 degrees. So we'll talk about that now. So let's look at the effect of climate change. So as we mentioned earlier, climate change is a natural thing, but what makes climate change at the moment a point of crisis is that we are facing rapid change in average global temperatures, and this is causing a lot of different problems, because even just a 0.5 degree change in the global atmosphere is currently making a big difference, in which storms are more violent, caps are melting, so on and so forth. And if we don't do anything right now to curb our actions, temperatures will rise to over 3 to 4 degrees Celsius globally as an average. Okay, and this will severely disrupt life on Earth. And so global research has stated that if we don't do anything to reduce our global temperatures to rise over 1.5 degrees, we will not be able to reverse this process, since it will sort of create a ripple effect, a chain reaction that we will not be able to reduce back to normal and return back to a stable state. And this is based off of the fact that carbon dioxide levels are continuing to increase, and also if they reach to over 450 parts per million, we will not be able to decrease our temperatures to less than 2 degrees Celsius, because remember, carbon dioxide has a lifetime of 100 years in the Earth's atmosphere. So people are saying that it's too late. Even if we do something now, we will not be able to prevent an increase to over 2 degrees Celsius by the year 2050 because of this lifetime. So we actually have to do something right now about it, and we need to start actively removing carbon dioxide from the atmosphere, because it won't sort itself out for the next 100 years or so. So in terms of rapidly induced climate change as a result of these rising global temperatures, one of the most worrying things is that temperatures over the polar regions are rising much more sharply than they are anywhere else in the world, and this is especially so within the last 50 years. And one of the things that the ice and snow does, which is kind of important, is that it reflects a lot of light out of the atmosphere, and so it kind of helps reduce the amount of heat that stays on the surface. And as the ice retreats, there is a larger amount of darker colored ocean water that then takes its place, which then absorbs heat much more readily than the ice, which then further accelerates ice melt, and this process becomes hastened. So the real threat exists not in the form of ice sheets that you see floating on the water, but rather land-based ice sheets that you find in the Arctic and Antarctic regions. So these together have the combined capacity to raise the global sea level by 61 meters. Currently, glaciers in these areas are melting and are already raising ocean levels, in which by the end of the century we might see ocean levels being over 2.5 meters. And this has severe impacts for many coastal cities as well as for island nations, but also we're not fully sure about the impact that increased fresh water will have on our ocean currents. And our ocean currents are very important in terms of regulating what are our normal climatic seasons. So on the topic of thawing ice, we have thawing permafrost. So permafrost soil is basically makes up 25% of the exposed land surfaces in the northern hemisphere. These are land masses that make up Alaska, Siberia, as well as Canada, and these frozen soils contain huge amounts of stored carbon reserves in the form of organic matter from millions of years ago, in which trees had fallen and then had just simply frozen instead of decaying and becoming like coal or something like that. And so rising temperatures are now thawing these frozen soils, and thus allowing microorganisms and bacteria to access these this ancient organic matter. And so it is now starting to decay, where it is being consumed by this bacteria and is thus giving off large amounts of carbon dioxide and methane. And it is estimated that the Arctic permafrosts have the capacity to generate up to 2 to 4 times more greenhouse gas emissions than was ever emitted by humans over our history. And this thus proves to be another tipping point in which, if the permafrost completely thaws, we might have a terrible situation I had, where even just a 5 to 10% increase in methane in the atmosphere will rapidly accelerate atmospheric warming. And you've seen how long carbon dioxide stays in the atmosphere, as well as how long methane stays, and also how much more severe it is compared to carbon dioxide. So looking at the rising sea surface temperatures, the influence that the sea has on our oceans, on our climate, is very important. And as they start to become warmer, they begin to increase energies that a storm can have, in which there is increased latent heat that is provided by the ocean, and so therefore gives added kinetic energy to a storm's force. And also, as global temperatures rise, they can also break down the local weather and climate systems. So not just the short term, but also the long term. And also, we also have rising sea levels as a result of ice melt, because the sea is warming. And so it's estimated that the ocean can rise by 1 to 2.5 meters by the end of the century. And it's very important to note that almost more than a third of the world's population lives on a coastline or less than 1 meter below sea level. And in South Africa, this could impact up to 10 million people should the water rise by this amount. So in terms of ocean acidity, the ocean absorbs up to 90% of the heat that we produce, and also a large portion of the carbon dioxide that is in the atmosphere. And as carbonic acid, carbon dioxide interacts with H2O, it forms carbonic acid, which is a weak acid that you normally find in soft drinks, and this process is called ocean acidification. So now, as the ocean's pH level begins to decrease, marine animals such as coral, snails, oysters, and other organisms that have shells that are made out of calcium carbonate are then placed at risk, in which this increased acidic environment decreases their ability to repair themselves or even develop or grow in general. And so a more acidic environment also will degrade phytoplankton populations, and these are tiny marine organisms that include algae species, which convert a significant portion of the planet's atmosphere. I heard it said that your algae within your oceans actually converts about 50% of the CO2 in our atmospheres, and the rest of the 50% are all from land-based forests, where most of the forests, especially within your boreal regions in the northern hemisphere, and also your rainforests along your equator. So going back to microorganisms in the sea, they form a very important food base in the ocean, and they also support a vast diversity of animals for their survival. And if these phytoplankton were to die, there would be a great loss of these species. Other impacts of rapidly induced climate change include a severe and prolonged drought, which we mentioned earlier, in which droughts will increase in severity, in which the evaporation rate will increase as a result of higher temperatures, and over a prolonged period of time, this will dry up our soil, and when you have dry soil, you cannot plant anything or make it productive. So currently, increased droughts are affecting about 30% of the Earth's land surface, which could rise up to 45% of the Earth being affected by dry and arid conditions by 2050. So droughts are a very normal phenomenon in South Africa, and happens on a cyclical basis. But as temperatures become more extreme, this can translate to agricultural shortages and lack in yields, and this will then transcend to impact on our economic and social livelihoods. It can also cause more extreme weather conditions, in which we have an increased frequency of strong storms, such as hurricanes or even hail events, and also heat waves can be more severe and last longer, and this will have an impact on people who are vulnerable, especially the old and the poor. And also cold snaps can become more frigid and more harmful. So some examples include last year's Beast from the East, in which there was a cold front that hit most of northern Europe, and this was because of a collapse in a weakening of ocean currents, which then caused more frigid conditions in the northern hemisphere. And so currently 300, but going on to temperature rise, currently 354 cities globally have an average summertime whose temperatures exceed 53 degrees Celsius, and by 2050 this could rise to almost 1,000 cities, and this will impact some 1.6 million people worldwide, and this can cause a mass exodus of refugees, in which they are fleeing their countries as a result of climate change. And this is already happening in some North African countries, as well as in your island nations, in which people are leaving their homes due to there no longer being land. It's just water now. And so this can then lead to future political tensions, especially when you've got so many people who are leaving a country looking for a place in another country. And this you could see with your Syrian refugees, in which they fled to Europe, and that caused a whole cascade of political and social issues where people didn't want them. And this will happen in many countries as a result of climate change, in which their crops will fail, they have no food, the only thing they can do is go to another country for a better livelihood, and they might not find very welcoming arms. So if we have a look at biodiversity, the South African National Biodiversity Institute defines biodiversity as being the genes, ecosystems, landscapes, and ecological and evolutionary processes that allow these elements of diversity to persist over time. Okay, so we're not just looking at animals, we're looking at the things that make up those animals, and also what those animals make up in terms of their surroundings. Okay, so then you have biodiversity hotspots, and these refer mostly to threatened biogeographic regions, where you will find a higher instance of species that have geographic rarity. That is to say that you can't find them anywhere else on Earth. And for biodiversity hotspots, we focus particularly on vascular plant species because plants do not move, and so it's much easier to use them as an indicator for biodiversity because animals tend to roam over large ranges, and so pinning down a specific geographic region for an animal is much more challenging than it is for sedentary plants. Okay, so that has its own complications, but let's continue on with what is a megadiverse, what is megadiversity. So megadiverse areas tend to be within multiple political boundaries, and they are also they show and display remarkable instances of endemism. So endemism is when you find something within a locality. So something can be indigenous and something can be endemic, in which something is indigenous, it is local to that country, but it is endemic when it is local to that specific area. And so in South Africa, we've got 3 biodiversity hotspots, which is actually quite impressive compared to some other countries which don't even have anything. In fact, the Cape Floristic Kingdom alone has more plant species than the entire subcontinental Europe, and also South Africa as a whole has more species of plants than the entire North American continent. So we, in this very small country compared to the rest of the continent as well as the planet, have a lot of geographically rare plant species on our amazing land. Okay, so climate change is now serving to threaten biodiversity, and as said there, biodiversity is mostly a measure of endemic vascular plants, and so because it's plants, they cannot necessarily move to a better environment like animals can. And when we look at climate change, it is shifting climatic zones, and so that's affecting these biodiversity hotspots because it is changing the environment to which these plants have become accustomed and evolved specifically to favor for. And so yeah, and then your most vulnerable ecosystems are your cold climate regions, such as in your polar areas, your species that live in higher altitudes, because now it's becoming warmer and their tolerances are changing, and also species with limited tolerances to temperature changes, such as corals, are being affected, and also species that have a limited range. So, for instance, you have what's called the ocelot, which is a little, it's sort of like a gecko thing that lives in a cave, and it is found nowhere else but in 2 cave systems in North America. I think it's in the Texas area, but if you don't know what it is, I can maybe just quickly show you here. I know this is a terrible thing, but you'll probably recognize what it is when I it's got like that. I'll have to pop in a thing there. But so as climate change begins to intensify hydrological droughts and shift climatic zones, farmers are faced with various challenges as a result, in which there are very few crops that are able to tolerate extreme heat and dry conditions, and many farmers in Africa already make use of genetically modified maize in order to survive hot, dry summers and winters. And increased temperatures will reduce the overall yield produced by a crop. So as a rule of thumb, an increase in 1 degree will decrease crop yield by 10% or so. It's kind of like a rule of thumb. And so also warmer winters will kill less pests, such as your weeds, insects, and also mold. This will affect agriculture in your northern hemisphere, and also hotter summers reduce the photosynthesis effectiveness of plants, and so they grow less fruit into harvestable product. So yeah, and then also if temperatures were to exceed 40 degrees Celsius, maize crops can fail almost entirely. Um, so yeah, and then also as sea levels will rise, they will change the flows of rivers in which they will become more saline. And so many farmers who are in your coastal areas will find that their water is now contaminated with increased salt, and they're also then vulnerable to flooding. Um, So also in climate change will also be a threat to human health as well as to national security, in which since 1980s heat waves have become more intense and more severe and also far more frequent. Um, and it's expected that this will worsen, and this will impact especially those who are old and those who are poor. The reason why is because this is not necessarily as a result of climate change, but is also amplified by the urban heat island, in which your city environment is actually also heightening the effects of heat waves. So old people, they are normally sensitive to heat, but also poor people, because they do not necessarily, they cannot necessarily afford things such as decent building materials that would not conduct heat as well or insulate them as proper, and also they can't afford, let's say, a fan or an air conditioning system, or even perhaps afford to live in a house that might have a garden in which the nearby vegetation, such as trees, would help to mitigate the amount of heat that they receive. So yeah, also warmer climates will also encourage the growth of certain insect species such as the mosquito and housefly, and these insects have been known to be vectors for diseases such as malaria, the West Nile virus, and also Lyme disease. And then also an increased atmospheric temperature can hold more water vapor, which in turn holds even more heat, thus creating what is called a photochemical smog, and this can cause various respiratory diseases. And then let's look at other risks to national security, in which we live in a globalized world, and many countries are reliant on other countries for various important resources. And so, as climate change intensifies drought conditions, many countries may make more stringent policy actions to secure their own domestic water resources. And so, since water is not necessarily a domestic resource and actually transcends, international boundaries, this may cause certain tensions with countries that are downstream of this resource. And then also, if we have a look at countries that have very little arable land, such as Singapore, rely on other countries for their agricultural produce, in which Singapore has actually bought land in other countries such as in China and India, so as to ensure that that land is made productive to support their own country. And so if these other countries, for instance, are hit by climate disaster, such as by a drought, flood, or hurricane, it then places the entire population of Singapore at risk, in which they derive almost 60% of their food from imported goods. And then people living in countries who are severely impacted by climate change will have to leave for better opportunities, as explained earlier from mass migrations of climate refugees. Okay, and now we shall have a look at how do we slow climate change. So, as mentioned earlier, dealing with climate change is not really a simple thing, because it requires the global efforts of the international community at large, especially from your largest emitters such as America, such as China, Russia, India, Europe, as well as from us, because we're one of the largest emitters on this continent, and it's important to consider the fact that climate change can't be stopped. Really, it can only be slowed down, especially since some of your greenhouse gases like carbon dioxide and NOxes will remain in the atmosphere for about 100 years or more. So even if we were to stop right now, we would still feel its impacts for the next century or so. And so also climate change doesn't affect everyone on an equal level. So people on islands, people in your desert regions, they are feeling it far worse than people in your temperate zones. Like for instance, Germany, for instance, they biggest issue right now is an increase in mosquito populations because it's getting warmer there. So as compared to your island nations like compared to your island nations which are having to evacuate completely. Um, and so also a big issue is that a lot of your countries are still too dependent on fossil fuels, and so phasing it out is seen as controversial and is met with a lot of resistance. And also people find it unfair that developed countries could get where they are because they used fossil fuels, but now developing countries cannot do the same, which we'll talk about just now. And so also climate change projections vary. So we don't really know what's going to happen in the next 30 to 100 years because, it depends on what we do. So things are either based on a worst case or a best case scenario. And so this ambiguity in our projections, leaves makes it difficult to argue against climate change denialists. And so we have to adapt or mitigate, in which and these are really our only real approaches to dealing with climate change, in which we can mitigate our actions, which means to reduce or avoid our current impacts on the environment, such as reducing fossil fuel use and reducing emissions, and we can also adapt, in which we can adapt to what is the inevitable and start preparing our communities for the impending climate-related impacts by preparing for intense storms and creating drought relief or flood relief mechanisms, such as aid or funds or some sort of a protocol that when an area is water sparse, we can then send reserves. So we start building structures to store water to last us throughout the drought season. And so the main aim of these actions is to try and prevent us from reaching a certain tipping point in which climate change will spiral out of control. And our actions are therefore aimed at managing the expected experience and impact by reducing the harmful effect and by reducing what is experienced by that impact on the community. Okay. So we can do this by reducing greenhouse gas emissions, in which we've shown that they are linked, and we have to reduce it by a significant portion, and this was what was part of the Paris Agreement, which kind of fell flat, and it led to mostly voluntary obligations, in which countries kind of said, well, we'll reduce our levels to less than 1990 or less than 2000, but like they didn't really commit in a sense. So this is one of the problems about trying to reduce our emissions, is trying to get international consensus on this. So as I said, many developing countries find it unreasonable that a developed country has achieved economic power through the use of fossil fuels, but now they can't do the same. And many economies and businesses are dependent on a fossil fuel economy. But we can also still reduce our greenhouse emissions through using cleaner and renewable energy sources, through making them more widely usable. But the problem is that they aren't as reliable as fossil fuel sources. So the wind can only blow for so long, and the sun can only shine for that long. But also these in themselves have their own environmental impacts. So for instance, solar farms have been seen to be burning any bird that flies over them. And so because solar farms are, they're bright lights in essence in the desert, and they attract lots of insects, which then attracts the birds, and as they fly over, their wings actually scald, they burn, because it's like flying through a magnifying glass. And also other examples are that wind farms are breaking the wind regimes experienced at coastal areas, and so thus actually reducing the amount of precipitation potential that goes inland. So yeah, so it's not all a perfect process, and also nuclear power, which is seen to be a clear energy source, is incredibly expensive to build, especially after 9/11, in which nuclear power stations now need to be terrorist proof as well. They need to be earthquake proof after Fukushima, and so they're incredibly delicate machines, but once they're going, they are quite reliable, but at what cost? Okay, and then also we can physically remove the carbon dioxide from the atmosphere, in which various efforts are being taken to lock or sequester carbon dioxide out of the atmosphere and place it underground. So you have what is called the carbon capture and storage strategy, in which companies are scrubbing or filtering their smokestacks by removing the pollutants, especially carbon dioxide, out of the smoke that is expelled, and then converting it into a liquid which they then store underground. A similar project is taking place in Iceland. I've seen a video on it in which they are dissolving carbon dioxide straight from the atmosphere, and then dissolving it into water, where they then pump it underground, where it then reacts with the geological formation, which then creates calcite. And this calcite which forms essentially solidifies the carbon and then forever locks it underground as a rock. So then a more traditional approach to removing carbon dioxide is in the protection of our global carbon sinks, and these carbon sinks are also to be understood as our rainforests, these being the biggest being in your equatorial regions such as South America and in Africa. And but the thing is, many trees are being cut down, which is quite problematic, especially since these trees are mostly of old or primary forest. And but various international tree planting programs are becoming integrated with corporate and country policies, and that's fine. We're planting more trees, but we cut more trees than we're planting, so we need to get that going. There is also geoengineering, and geoengineering is pretty much the human way of doing things, in which we just mess the environment even more to try solve a problem by creating more problems. And this is given to be in exploiting or manipulating the environment to suit the needs of development, where some solutions to combat climate change include building giant mirrors which would then orbit the Earth, and then would reflect incoming solar radiation, so that is expected to then cool the Earth. And then also we might release sulfates into the upper atmosphere, which would then increase global cooling. So just a note on this, I think it was in the early 1800s or so, there was the eruption of Krakatoa, which emitted vast amounts of sulfates in the atmosphere, and this then created what was called a mini ice age. And for quite a few years, winters were much colder and summers were much cooler than they normally are because of the presence of these sulfates. So that's kind of where this idea is coming from, in terms of artificially then changing the concentration of sulfates, but who knows what impacts this would cause. And so also there are other ideas of building massive ships that would then expel large amounts of water vapor into the atmosphere, and these would be computer controlled. They would then go about the sea, and then they would create sites of evaporation, in an attempt to create low lying clouds, which would then further reflect incoming solar radiation. And then another, the last one we'll look at is manipulating algae by feeding them with nutrients, such as nutrients found at the bottom of the ocean, or actually using iron pellets. And then because algae consumes large amounts of carbon dioxide, by seeding them with nutrients or iron pellets, we might be able to get rid of most of the carbon dioxide in the atmosphere. But we might be poisoning our oceans. There might be toxic species of algae that might form, and this might kill all sorts of marine species. And also the thing is, we're not actually dealing with the problem at large. We're dealing with the symptom. So instead of actually reducing our carbon dioxide emissions, we're just reducing the amount of heat experienced. So we're more creating other problems, but not dealing with the core problem at hand, and that is our consumption of fossil fuels. So another thing which probably might work the best is if we put a price on our emissions, in which we base it on the polluter pays principle, in which a person who pollutes more, or a corporation that pollutes more, will be taxed on what they are polluting. So this price is intended to increase on an annual basis until your emissions are where they need to be, in which it has been recommended that they start at about $8 per ton, rising up to $40 per ton to the year 2030. And this has been seen in our climate change bill, which came out, I think, in a year or two ago. And this is mostly focused around the polluter pays principle in terms of delineating how much you can pollute, and in terms of working out the accounting around emissions and emissions costs. So increasing carbon taxes is meant to coincide with a decreasing living income tax, and this is supposed to make it more workable in society. Whether or not we will see that happen is will remain to be seen, because at the end of the day, country gets money, and who would want to stop a country getting more money, even if it's from its own tax base? But let's continue. So there's also the cap and trade, or emissions trading method, and this works differently to taxation, because this is between the companies and not necessarily an interaction between the country and the company, the state and the corporation. This is an intercorporation thing, in which it works around the idea that corporates will receive a limit on how much pollution they can produce, and if they cannot reduce their limit, they then need to purchase credits from other companies who are able to reduce their emissions. So if, for instance, I'm not allowed to produce 10,000 tons of carbon dioxide, but I only produce 9,000 tons of carbon dioxide, I then have 1,000 carbon credits or whatever that then I can trade with a company that is not able to reduce their emissions. So the idea is to try achieve a global net zero on emissions, but this process hasn't worked as effectively as directly taxing companies. And that is it. Thank goodness. I'm sure you guys are all relieved. I hope this has been okay. I hope this has been informative. If you guys have any issues, please don't hesitate to ask. This is available in the PDF document I provided, which is called Living in the Environment, and I know that it is 4 years old or 5 years old, but it is still relevant. The work is still there, so check on chapter 19 of that PDF textbook that I sent, and we will then continue on Thursday with Climate Change Part 2, where we will look into topics more closer to South Africa, and we'll focus a little bit more on the legislative and policy side of things. Thank you very much, guys. I hope you have a lovely day, and keep well and stay safe.